Hello everyone. In our previous lecture of structural analysis, we have understand about the two span continuous beam, three span continuous beam is analyzed by moment distribution method. In that case, we have steps of MDM method. First step is find out friction moment. Second step is find out distribution factor. Third step, that is moment distribution table. Fourth step, span moment. Fifth step, reaction. And sixth step, that is shear force diagram. Now we are going to start analysis of a frame. Means here it is portal frame, and we have clear idea about the portal frame. The portal frame is jointed by rigid joint. Means for that, first of all, we have to find out degree of static indeterminacy. After that, we are going to solving that frame by moment distribution method. So you have clear idea about the moment distribution method which is used for beam, but now the same concept is used for frame of the structure. Now we have two type of portal frame. First one is sway frame and second one is non-sway frame. What is the difference between that? We had understand that thing in our previous lectures, the theory portion of frame analysis. So let's again repeat that thing. Whenever our frame contains horizontal force, that frame is sway frame. Number two, if column of that frame having different height, then that frame is sway frame. If support condition of the frame contains column having different support, it is sway frame. If modulus of rigidity means it is a flexural rigidity EI is different for the column, then it is sway frame. And the last one, eccentric load is there, then our frame is sway frame. So dear student, first of all, what we are going to do, we have to first identify that whichever frame is here from that two type. If it is a non-sway frame, then the analysis of that frame is very much simple, same like as beam. But whenever it is a sway frame, the calculation is lengthy and tedious. So let's start with frame analysis with the help of moment distribution method. Now for understanding of this non-sway frame, first I have taken here the non-sway frame. For the understanding of the non-sway frame, I have taken here one simple example. Here, what is the example? Let's start. Draw shear force diagram, bending moment diagram and axial force diagram for the frame shown in the figure below. Here, this is our frame. Vertical is the column AB and BC is the beam. AB contains 20 kilonewton per meter load of UDL and BC having 20 kilonewton per meter load. The AB span is 3 meter and BC span is 2 meter. So, and EI is the constant. Now, whenever this kind of spray, dear student, here the frame is non-sway. Why? Because having a single column. Whenever this frame is going to bend towards the direction of X, then the reaction of this support must be stabilized that frame. So it is non-sway frame. Clear? Now let's start how to solve this. So for that we have to, whenever the non-sway frame here, then this frame is considered like a beam. AB and BC means this is a two span continuous beam. So first step, that is finding out the fixed end moment. For that, MFAB is equal to minus WL square by 12, that we know very well cause it is the same as we discussed in a beam portion. So here it is minus 15 kilonewton into meter. Now MFBA, it is plus WL square by 12, again it is 15 kilonewton into meter. MFBC minus WL square by 10, again that is UDL, so it is minus 6.67, and MFCB is equal to WL square by 12, 6.67 kilonewton into meter. So this is our fixed end moment. For the non-sway frame, we have to consider that our frame is like a two span continuous beam, as we discussed. So the next step, that is we must have to finding out the distribution factor, and this distribution factor is depending on the stiffness of the member, support condition of the member, and EI of the member. Okay, so the B joint is our common joint for AB and BC two span. So here the first joint, that is B, and B having two member, that is B2A and B2C, right? So whenever the far end means here it is A is fixed, then for EI by L, and C span, that is simple, so it is 3 EI by L. We can choose anyone. It is depending on the end condition, means it is fixed or continuous or it is simple, then the K must be changed from the equation. So here 4 EI by 3, so we will get 1.33 kilonewton, and 3 EI by 2, again we will get 1.5 kilonewton EI. So summation of these two stiffness is 2.83 EI. Now the distribution factor must be getting from the K upon sigma K. So first 1.33 upon 2.83, we can get it is 0.47. So this 0.47 is distribution factor of AB member, and the second, that is 0.53, is the BC member, but at the joint of B. So whenever we want to check it is okay or not, then we have to summation of these two, and it must be 1. So we are correct. Now joint A and joint C. If joint A is fixed, then the distribution factor is 0, and at joint C it is simple, then distribution factor is 1. So after getting this distribution factor, we must calculate that the moment distribution table. So why we are going to do that table? Because we are going to here distribute the moment from one joint to another joint in the way of using the stiffness of the member and end condition of the member. So we have this kind of thing. So now the moment distribution table is something like this. This is the same as we discussed in a beam. First A joint, second B joint, third is C joint. Here we are taking the reference line from this support, and first we are writing the distribution factor. At A, distribution factor is 0, at B it is 0.47, at B to C it is 0.53, and at C it is 1. This distribution factor must be getting from the distribution table that we discussed. Now the fixed end moment. This fixed end moment, we have already calculated that the minus 15, A to B, B to A, that is plus 15, B to C, that is minus 6.67, and here C to B, that is 6.67 positive. Now whenever we have this impulse support, then what we are going to do? We must getting here the zero value, because we know that the simple support having moment is 0, but here we have that value, so we must have to zero this value with the help of balance and initial carryover. So for the balancing this 6.67, we must have to put minus 6.67 here, so we will get 0. But whenever we are taking some balancing moment, that we have to half of that distribute at the another joint. So here at C we have taken minus 6.67, then half of this at B it will minus 3.33. So finally we get the initial moment, that is minus 15, because here in A to B there is no balance and carryover. So we will get directly minus 15 and plus 15, but here it is minus 10 and it is 0. Now this is initial moment is ready for the distribution and carryover, and from here we will always take the sum from the initial moment up to whenever we will get the 0. So dear student, now for the balance, what we are going to do? Here for the balance it is minus 15, but it is multiply with distribution factor, and that is 0. So here we will get 0. But here in these two, we are going to take a difference between these two. It is plus 5, and we are going to balance that plus 5. So we must have take that minus 5. So our beam is balanced or our frame is balanced. That minus 5 must be multiplied with 0.47. So we will get 2.35, and again minus 5 must be multiplied with this 0.53. So we will get minus 2.67, and here 0 must be multiplied with 1, that is 0. Now after balancing the moment, we will take distribution at the another joint, that is called carryover, and we know that carryover must be half, and whenever the simple support, carryover must be 0. So here this 2 is fixed, because fixed here A is fixed and B is continuous. So here half of this is 0 and here half of this is minus 1.175. Here minor mistake is there, it is minus because the moment is minus. So and here it is 0 and here also 0. Now the carryover is done. Now balance. For the balance it is 1 minus 1.175 multiplied with 0. Then it is 0. Here 0 multiplied with, then this 0. So whenever at the stage of balance, we know that it is 0, we are stopping this cycle of balance and carryover. So finally, let's start with summation from here. We will get minus 15 minus 1.175 means almost 18. Then we will get minus 16.18. Here summation of these two plus 12.65. Here summation of these two, it is minus 12.65. Whenever these two is the same, we will satisfy with the correction. And here it is 0. So, for this frame, finally we will get the support moment, that is MAB is equal to minus 16.18 kN. For B2A, it is 12.65 kilonewton into meter. From B2C, it is minus 12.65, and here it is 0 at C2B. So, this support moment must be used for the draw of bending moment diagram. For that, we must have to first finding out the span moment, and the span moment is directly we can get from the equation. Whenever we have UDL, then it is plus WL square by 8, and here we will get 22.5 kilonewton into meter. So, and the span BC, it is again WL square by 8, and we will get 10 kilonewton into meter. Now, for the bending moment diagram, what we are going to do? We must have to first draw this frame A, B and C. Here at A we have anti-clockwise moment, that is 16.18. Here it is plus 12.65. Here it is again minus 12.65, and it is 0. So, first we have to draw this negative diagram from here to here, and for this the negative diagram from here to here. And we have the span moment, that is parabolic curve with the help of the value, that is 22.5, and this 22.5 must be written over here, and this is our positive diagram, and here it is 10. So, we are putting this positive diagram over here. So, this is minus, this is plus, this is again minus, minus, plus, and the H area is our net bending moment diagram for the frame. In this case, must consider that the at common joint B there is 12.65 moment is must be for the span AB and span BC. So, it is for the two span. So, we have to draw something like this. Clear, everybody? This bending moment diagram is used for the design of any section, that is you have the another subject design of structure, and in that case Deepika ma'am going to teach you the how to design the member with the help of bending moment diagram, and this bending moment diagram is used for the designing of any section. Now, the next step, that is calculation for the shear force diagram, and we know that for the shear force diagram we must have to finding out the reaction, but in the case of a frame we have to first balancing this column, and for that we are finding out the reaction, right? Equilibrium of column must be consideration by us. Here let us see equilibrium of AB, and for the equilibrium of AB what we are going to do? Here on AB there is 20 kilonewton per meter UDL. This is B. At B joint clockwise 12.65 moment, and here anti-clockwise 16.18 kilonewton into meter moment. And here what we are going to do? We are finding out the horizontal reaction at A, and that horizontal reaction must be finding out with the help of equilibrium of AB. This equilibrium means the sigma MB is equal to 0. So, we are going to take moment at B. So, here HA into 3 is clockwise, and 12.65 that is clockwise. Here 16.18, that is minus, it is anti-clockwise, and 12 kilonewton into 12 kilonewton per meter, that is UDL, and the moment by this UDL 12 into 3 into 1.5, that is anti-clockwise. So it is equal to 0. From this we can get the HA, that is 31.17 kilonewton, and we have assumed that the HA is towards the left. So we will get this positive value, means our assumed direction is correct. So HA is towards the left, and that is 31.17 kilonewton. Okay. Now the one horizontal reaction is finding out by us. Next, now the equilibrium of whole. Whenever we have two column, then we have two equilibrium of that two. Whenever we have single column, then equilibrium of that single column. Now the moment is used for the finding out the reaction of HA. Now we will get the vertical reaction with the help of the equilibrium of whole frame. In that case, first sigma H is equal to 0. Here HA we have towards the left 31.17. Now we have to find out VA, VC and HC. For HC, the summation of horizontal force is 0, means HA plus HC is equal to 20.20 into 3. It is towards the right. Then HA we have, so we will get HC is equal to 28.83. Here we have assumed HC towards the left, and we will get the positive value, that is 28.83. So the HC is equal to towards the left. Now taking moment at A, somewhere here we are taking moment. So what we will get? We have that VC is equal to moment at A. This is anti-clockwise, VC into 2. Now this HC into 2, sorry 3. So it is anti-clockwise. And here 20 into 3 into 1.5, it is clockwise, and this is again clockwise, 20 into 2 into 1, it is 0. So we will get VC is equal to 21.75. It is also positive. So our assumed direction of VC is plus. So it is plus, means it is upward. Now the vertical is 0. So sigma V is equal to 0. Then we will get VA plus VC is equal to 0. Then VA is equal to 40 minus VC. Right. So we will get VA is equal to 40 minus 21.75. So here we have VA, that is 18.25 kilonewton. Now here we have all the vertical reaction, we have all the horizontal reaction. Now we will ready for the drawing of the shear force diagram as well as axial force diagram. For shear force diagram, we are going to take shear force of the member. And what is the meaning of shear force? Whenever our column is vertical, then horizontal force is shear force, and member is horizontal, then vertical force is shear force. So here we are taking the horizontal force as HA, means HA is towards the left, then 31.17 is towards the left. Now it is minus 20 into 3, so we will get 28.83. So finally we will get the shear force diagram of AB. Now for a BC, here vertical force, that is VA, and VA is 18.25 minus 20 into 2, so it is 21.75, it is plus. So plus minus, the shear force diagram is something like this. Now the axial force diagram means whenever our member contain compression, then it is plus diagram, and whenever it is in tension, then it is minus diagram. So in axial force diagram, for the AB member, vertical force is axial force, then vertical is 18.25. So the compression is 18.25 in AB, that is plus, because it is compression. And for BC again, HC is towards the left, it is compress our member. So Here it is 8.83 as a positive axial force diagram. So now, dear student, it is a simple frame, that is non-sway frame, and it is must be calculated with the help of simple as a beam. The diagram is little bit different that we have understand over here. So these are the calculation, and from this calculation we will get the clear idea about the how to analyze the frame. In our next lecture we are going to analyze the again non-sway frame, but having 3-span continuous frame. Here it is only 2-span continuous frame. So we will get the clear idea about it. And dear student, whenever we will get the frame, first we have to consider that it is sway or non-sway. Now in next lecture we are going to take another example for the frame. Thank you very much.